It's very rare that in isolation an LLM is actually useful. Very rare. It can be fun. It can be fun to just chat to a model, and it can be pretty good at helping you write stuff. So it can help you do copywriting. But overwhelmingly, I think the real value we'll find from LLMs is in plugging them into broader systems.
Interesting to hear you say that, right? That the enterprise, we have to recognize that there is going to be a vulnerability in this technology, that perhaps liability shouldn't pass back to the enterprise.
That's something that sort of disappoints me about AI, is that there is this facet of entrenching value. Like the folks who have already won the last go around, they're in the best position to win this next go around. And AI might make it easier for them to not be disrupted. That actually frustrates me.
Hi there, I'm Azeem Azhar. Now, my guest today has become one of the most important figures in artificial intelligence. You could say, no, you can say that he was present at the kindling of the current firestorm of innovation and investment. At only 20, when he was an intern at Google, he co-authored the paper Attention is All You Need back in 2017, which introduced transformers to the world. Transformers, as faithful listeners will know, are the T in GPT, this AI architecture that is taking the world by storm. 2 years after publishing the paper, Aidan Gomez co-founded Cohere. It's now one of the major AI companies specializing in serving businesses. This gives him a unique vantage point on how cutting-edge language tools are entering the real economy, how firms are using them, what's working, what they're finding hard, and how it's changing the everyday rhythm of the employee. Now, recognizing his contributions in the field, Time magazine named Aidan as one of their 100 most influential people in AI. But perhaps more importantly than some magazine accolade, I think he's someone who's really worth spending time with. So Aidan, it is great to have you on the show.
Stoked to be here. Thanks for having me.
Now, you've just moved to London. Congratulations. How are you settling in?
I love it. I love it. I've always described London as like the midpoint between New York and Toronto. So I grew up in Toronto, but one of my favorite cities on earth is New York because it's so alive. There's so many artists, different people. It's really heterogeneous. There's so many different ambitious people working on their thing. And I love New York, but I couldn't live there.
It's always on.
There's something happening every single night. I don't know how anyone gets any work done. And so London is like this perfect middle ground between Toronto, which is calm, chill, and New York, which is just super exciting. It finds that sweet spot.
And you've got some British heritage as well that brings you here, I think, both from family and from some of your studies as well.
Yeah, I did my DPhil in Oxford, and then my mom's British, so I'm British. Most of my family is here in England, so it's nice to be here.
Yeah, you get some family time when you're not building Cohere. So the Cohere story, I think, is pretty interesting in the sense that you were one of the original authors of that key transformer paper, and you've gone off and built a startup, as many of your co-authors have. But I'm quite curious about what it was you saw when you were putting that paper together with your colleagues back 7 years ago. What was the thing that you thought you had alighted upon?
Like you said in the intro, I was like the baby on the project. I was 20 years old. I couldn't get beers after work with my co-authors.
You should have done the research in London, because at 20 you can get beers.
I know you drink, yeah.
With a plum, right?
You go to the pub, yeah, it's so true. But maybe the paper wouldn't have gotten done because I wouldn't have time to focus. So I was like and it was really my first experience doing real research, very high intensity bursts, sprinting to make the paper deadline for a conference. And so I think I got thrown into the world of research in potentially the most intense project anyone can be thrown into. The Transformer paper came together over the span of something like 3 or 4 months, so a really short period.
Right. Very short for research. Yeah.
Yeah. So the team came together, consolidated on the code base that Lukash and I were building. There were two different groups. There was Gnome, who was operating alone, working with attention and language models. And then there was Yakushnicki in Translate, doing some thinking along similar lines. And we all just decided, let's deduplicate, let's team up and do it together. And that happened 2 weeks into my internship. And internships are like 3 months long. And so after that, it was just a total sprint to the finish line. And I think when people ask me if I had any inkling of what would come of the transformer, the answer is unequivocally no. I just thought, this is what research is. Every time you do research, anytime you try to improve a benchmark, this is what happens. So I got a pretty biased perspective onto the process. But I think there were some glimpses of stuff starting to work, like the platform tensor to tensor, which is, if you look at the code, it's something to behold in terms of its chaos now.
Right.
But what it was developed for was really scalable training. So even back then, we were thinking about scaling. We wanted to train on not just hundreds of GPUs, but thousands. And so that was built in from the start, this notion of scale. And what's interesting is multimodality was also built in from the start. We wanted
so multimodality meaning the ability to look at text and video and audio and other types of data.
Bringing together all of these different sources of data into one platform. And so architecturally, the code base really had the elements of the stuff that we're looking at today, which are these massive multimodal models, just 6 years early. And so I think we had the building blocks in place, but really, I think the credit goes to Gnome and OpenAI for really having the guts to push forward on scale. That was something that even back then you would joke about. You would say, deep learning researchers, they're so dumb. They just say bigger models better.
Give me more compute.
Yeah, just add more layers. It gets better.
Yeah.
But it was a joke. And no one actually took it seriously that we should be pressing on that basis.
But can I ask, what have you seen in the outputs? The thing that we think about with transformers is that they could produce realistic sounding text, and we're used to that with GPT-4 now. When we saw GPT-3, I think the average person was a bit unimpressed, but developers were quite impressed. GPT-2, I think you had to be working in the field of machine learning or natural language to be impressed with the output. And the average developer would say, what am I going to do with this? The transformer paper was, I think, was it BERT was your, or BERT came afterwards, but the initial transformer paper, you had something working. What were you actually seeing as the output that also made you think there's something interesting going on here?
Yeah, we built it for Google Translate. And so translation was the principal application that we were trying to make progress on. Very shortly after submitting the paper, Gnome started training language models with it. So obviously translation is you give it a sentence in one language. You ask the model to translate it into another. Language modeling is just purely generating text. And after my internship, I returned to Toronto. I was back at U of T, the University of Toronto, and I got an email from Lukash, which was like, Aidan, check this out. And it was a Wikipedia page with the title being The Transformer. And I was reading, and then it starts going into the story about this Japanese punk rock band that the bassist left and they replaced it with and they put out these albums. And then at the bottom, Lukash had written, I just wrote The Transformer and the machine wrote the rest. And so that was surreal. This was 2 weeks after the Transformer paper was submitted. Before one, before BERT, before edit. And so that was like hugely shocking. The fact that these models could produce such compelling, convincing text.
So you had compelling text. It was convincing. It also had a bit of topic drift, shall we say, because it started talking about transformer models and ended up with a Japanese punk rock band.
Yeah, it just hallucinated completely. Lukash only wrote The Transformer, and it decided that this Wikipedia article would be about music.
Oh, I see what you mean. Okay, fair enough. Makes sense. Makes sense. Okay, so there is the moment. There's a moment, and you went off and you founded Cohere. And the way that I think about your company Cohere is that you are building not just LLMs but other AI tools for enterprises, for businesses. And this is a really interesting space. I'm so curious about it because we see a lot of the consumer applications every day. You're in Mid-Journey and things that OpenAI has produced and Bing Chat and so on. And we read about the largest banks in the world building their own LLMs, but there are tens of thousands, hundreds of thousands, millions, in fact, of other companies in the world. So getting your insight on that, I think, is so powerful. Let's just start with, what are you seeing with enterprises in LLMs? Can you generalize about the kinds of things that they are building?
Yeah, I can. I would say the world woke up last year to the technology. That's really when things started. I've been building Cohere for about 4 years now. And up until last year, I would try to sell the technology. I would come and pitch, tech teams, C-suites, and they would be like, that's a really cool research project, but thank you, we're not looking for this. And it was like that for a long time. And we would be like, we promise you this is going to be important. Please care about this. And then last year, some switch flipped in industry. And everyone just suddenly actually saw what the technology could do. And they started to have their own ideas about how this...
Was that before the ChatGPT release or after, do you think?
No, after ChatGPT. Once they were able to actually interact with it themselves, they started to come up with their own ideas for, we could deploy this in our company to help our wealth management team. We could deploy this to our customers to help with customer service. So they came up with their own product ideas. And that was really the light bulb on moment, was people getting first party experience and coming up with their own ideas about how to use it. Still, I'd say last year was the year of the POC.
Right, like the proof of concept.
Yeah. In terms of real world production usage, like only those who were already working on it before it became obvious.
Like and when you, with these conversations that were happening after ChatGPT, who called you back? Because often with enterprise software, I'm going to call Cohere enterprise software, it's a sort of VP in the CIO, the chief information officer's line organization, who will have the call with the Databrickses or the Oracles and potentially the Coheres. But one of the things that I noticed last year in the conversations that I had with senior execs, quite often at the CEO level of large public companies, was that they had a handle on the LLM world and the LLM project. They'd been using the tools themselves, perhaps with their kids. And there was a sense in many conversations I had that there was this upward super senior level interest that I hadn't seen in any of the previous technology waves since the internet in 1994 that I have experienced or observed. What was your sort of on the ground experience there?
I think what you described with the developers were impressed by early forms of the technology. They were starting to get clued in before anyone else was, before the general public was. I think that's true. And within these organizations, a lot of the tech teams, they were excited about this. They wanted to. But for the most senior folks, or for the product organization, they didn't see an opportunity. They didn't see an opportunity to adopt it. And so once they actually got their hands on the technology, to experience it firsthand, then they did. And that unlocked, writ large adoption. I think your point around it being top down is also true. I would say it was just everyone woke up, and that included the tops of the organizations. And once the top of the organization has said, we want to explore this, that unlocks everyone else to go and start playing around with it. So yeah, last year was like the year of the POC. And in the back half of last year, we started to see those POCs coming to fruition and into production. And so I think
So what does a
now,
POC, a proof of concept, mean in the context of an LLM project? Is it?
yeah, so I think the organization was getting familiar with the technology. So they saw, okay, we want to do something. What do we do? And so they would come up with different use cases, applications within the organization, and then they would just start building and experiment. That's what the POC is basically there to do. It's to give people familiarity. But now it's starting to shift into production. So now those workloads, which before were like 5 people on a team playing around with a model, seeing if it can do this, turns out it can do this. And now they want to push this to product. Now they want to put this in front of users. They want to get it into people's hands.
And users could be internal employees, or it could be external customers or suppliers in the case of an enterprise.
Yeah, exactly. I see 2 sides to adopt. And one is on transforming your external facing product. So adding new product features, stuff like what we're doing with the Oracle Fusion App Suite is just adding a whole new suite of features, of 25 of them. The other side is internal facing. It's augmenting your workforce with these models to make them more productive or make their jobs easier. Yeah, so it's both sides.
So let's get specific about the types of things, applications that you've seen. Now, in the sort of external world, the general sense is, people will do this on customer service, because customer service is something we've been willing to automate and outsource and put into other countries. So we can just do this, and we've already got the data set. So I'm going to ask you not to talk about customer service applications here, and instead tell us about the surprising and impactful kind of applications you've seen Cohere customers build in POC over the past year.
Yeah, it's when people ask me that, it's really tough to bucket the applications because they're so diffuse. They impact every single vertical. Anywhere there's language, you could throw one of these models to extract insights from that language, to manipulate the language, to create a product experience around it. So it impacts every single vertical. We have customers who are large infrastructure insurance firms who are augmenting their employees with a model-based research assistant to help them speed up the time to a response to an RFP for an insurance project. And then on the other side of the spectrum, we have SaaS companies which are taking call transcripts and extracting action items or summaries. Then we have, of course, customer service. We have people doing sales team augmentation for email drafting, follow-ups, coaching of onboarding new sales staff. So essentially anywhere you have humans, language,
anywhere you have,
and then you can start injecting these models to make things more efficient, to create a better product experience.
So what it sounds like, though, is that you need to have a good understanding of the tasks that an employee undertakes, and then be able to map the potential to augment the performance or the productivity on a particular task against the kind of cost of building a reliable LLM-based system. Is that the sort of internal trade-off that is going on?
Totally. I think so I described the 2 halves, right? Like the internal facing use cases and then the external facing. For the internal facing, that's exactly it. You basically ask, what does an employee do day to day? What do they not want to be doing? And can we use an LLM to take that and do it for them? So that's one side. On the other side is just like, how do we make our product better? How do we make our users' lives more delightful, build a new product experience? Because people do love to interact with this tech. I talk to models all day, and lots of people do now, thanks to these consumer chatbots, which are out there. And so users want it. And so that's a huge drive for product teams, is to actually deliver that experience to the user.
Yeah. It's quite interesting, though, that what we're describing here, the point is that these are such general purpose or generally applicable technologies, because it's anywhere language is used, and it's anywhere where there is, even data that is in that format. So one of the things that I often hear is, where do we actually start? right? What's the first thing that we can do? And senior execs, I talked to somebody in a business with trillions of dollars of assets under management in the last few weeks. And one of his observations was, yeah, we've all played around with ChatGPT. And we've done that. We've done that first step, which is get a feel for the technology yourself. It's an ocean boiling exercise, isn't it? Because you've got 100,000 employees or you've got 100 employees. They spend virtually all of their time in the space of language. So how do you actually find an anchor point to get going? And that is something that I hear quite regularly. And I'm curious, like, what do you do to find that anchor point?
I think the first thing is to start writing down that list of the 100 things you could do, and then just start crossing off the items which you're going to get from someone else. Like your email client is going to have auto drafting, right? And spell checking. You don't need to build a spell checker or an auto email generate. So start crossing off the things that are going to come in the SaaS that you already consume and focus on the things that are differentiating for you. So something that will give you, in particular, an edge over your competitors. Look at the data that you have access to that you could use to augment these models to create something valuable. And then prioritize those. So don't go for, we're going to build, the 10,000th autocomplete application. Instead, look at what's differentiating for you inside your market.
Right. And so that differentiation is going to be around proprietary capability that a firm might have. And that capability is a combination of internal know-how, position in the market, and as a necessity to having either of those, you've got proprietary data. And that falls out of the space. So in a way, it's about finding areas where you are strong rather than finding areas where it's easy. Again, customer service to me seems like it's an easy problem because there's a couple of decades of turning it into a process and creating knowledge bases and automating what you can through simpler technologies. But the tougher end is where it's at the core and the heart of a company's business and decision making as that moves from the new proposals they respond to through to more strategic questions, right? So that's a harder kernel. And I'm really curious about what you've learned about the decisions that companies take when they go down that journey to finally say, to quote John Kennedy, we're going to do it because it's hard, not because it's easy.
Yeah, I think it's tough to paint the adoption of generative AI with one color. I think there's kind of two camps of organization that I've watched. There's one which gets stuck in POC, perpetual POC motion.
Right.
Go from one POC to the next, and they never commit. And that can be for a bunch of different reasons. It can be because they're ill-prepared to assess whether the POC is a success or not, and so they don't know when to commit, and they're just trying things and getting familiarity. That can waste a lot of time and a lot of resources. If you have teams in your organization all in parallel pursuing POCs in a cycle where they just drop that one and say, yeah, it was pretty good, let's try that next. At some point, you need to commit, and you need to get to trial. The folks we've seen succeed the most, they have a really strong product conviction about what they want to do. They almost don't need to do a POC. Like the POC is a formality, but they know they're building this feature. Their users need this feature. This is going to happen, and it's just a matter of time. So I think that's where we've seen folks succeed, when they have that conviction.
I'm smiling because what you've just described, you could have described about any previous strategic decision a firm would have made over the last 20, 30, 50 years, right? Those who simply experiment and never commit behave in one way, and those that have a sense of strategic direction and are able to marshal the resources and act with conviction end up being firms that behave a different way, often more successfully. And I'm curious about also what it means to build these technologies. So I've argued that one way to think about an LLM is like the engine of a car. It's essential, but it's actually only one component of the full working product, right? A car needs seats and brakes and axles and other car-like things. I'm not a mechanical engineer, so I don't know what else there is as a stereo as well. How do you think about this? Is it really, it's an LLM, the LLM can generalize so well across such a wide space that you just need an API and you send in a query and you get the answer you need? Or is it actually a kind of more complex, compound architecture of which one or more LLMs are merely a component?
I think that your description is accurate. It's very rare that in isolation an LLM is actually useful. Very rare. It can be fun. It can be fun to just chat to a model, and it can be pretty good at helping you write stuff, so it can help you do copywriting. But overwhelmingly, I think the real value we'll find from LLMs is in plugging them into broader systems. So having them as a component within a much larger system, whether that's RAG, where you're plugging it into proprietary knowledge bases. Maybe
so RAG is retrieval augmented generation, where the LLM can go off and retrieve a specific sentence or piece of information that could be accurate.
Yep, I should explain that. So you sit your LLM down next to, like, normally the LLM has just seen the internet. And so it knows what's publicly available on the internet, but that's not actually that useful to you as an individual, right? What I want to do is I want to sit it down next to my personal emails. I want to sit it down next to my calendar, my stuff that it's never seen before and that it otherwise wouldn't have access to, and let that model query those private sources of knowledge, pull back information that might be helpful and relevant to what it's doing or its response, and then use it. So that's super important for businesses and enterprises, because they're sitting on these troves of data, which are proprietary, and which these models have never seen, internal documents, et cetera, et cetera. And so having RAG, having the ability to pull from private sources of knowledge is crucial to getting value. And beyond that, I think tool use in general, the ability for these models to use tools, to interact with APIs, systems that we've built for ourselves, I think that's the value unlock. Once we can actually give these models access to this broad system of tools that we built, and they can actually go out and do work for us. So they can affect change in the real world, their impact on the world. It goes from, in the chatbot scenario, the model's impact on the world is a string of characters that's coming out of it. Once you're able to plug the model into APIs and tools and knowledge sources, it can now actually do work. It can affect change in the real world. And that's where the value.
Because right now what the model does is it does, in a sense, some of the thinking, right? And then it tells us, now you go off and do A, B, and C, and we're literally left doing the work. And I'm curious about how organizations are tackling the reliability question. And I know you've come from Canada, and I'm sure you may have seen the story about the Air Canada chatbot that promised a particular type of refund to a customer. And Air Canada and their Weasley lawyers tried to do the most Weasley thing and claim they weren't responsible for the chatbot and it was its own legal entity. Good luck with that. They lost. But we also saw Chevrolet of Watsonville, a car dealership, sell a car for $1 through its chatbot. And a lot of people, of course, are familiar with this idea of that models confabulate because of the nature of the data representations. And so there isn't the same degree of reliability that perhaps we're used to when we're using a traditional SQL database. How have your customers contended with the reliability question? How nervous are they, and what are they doing about it?
So I think the Air Canada example is, it's one of those stories that comes up early in the adoption of a technology.
Right.
You have people who aren't familiar with how it works, the fact that it is exploitable, and the fact that it makes mistakes. And we're seeing the legal consequences of that. I think both the court system and the public and the enterprise world need to come to terms with how we want to deliver this technology in a way that doesn't actually hold the enterprise accountable to a model which can be tricked or exploited. A user can maliciously come on and say, hey, give me that car for $1. Hey, give me that flight for free.
Okay, so that's interesting. It's interesting to hear you say that the enterprise, we have to recognize that there is going to be a vulnerability in this technology, that perhaps liability shouldn't pass back to the enterprise.
Yeah, if I talk to a bank with $1 trillion of assets, chatbot and I convince it to transfer me $500 billion, that bank is not going to actually transfer me $500 billion. That's ridiculous. I've exploited a silly chatbot to tell me that the bank is okay with that. It's a ridiculous notion to say that the enterprise should actually be accountable to what a chatbot, which is very clearly denoted to as a bot. I think that in reality, what we have to do is just make it clear to the user, this is a chatbot. It is not authorized to give you discounts or change prices on any of our products. You just need to make that clear as an enterprise, and then you're covered. And whatever that chatbot says, it's a chatbot. Be told you can't do that, so it doesn't matter. Once we actually have that infrastructure in place, and once the courts start to recognize the technology for what it is, a fallible system which can be exploited, we'll get to a more stable spot. But this is the story of early technology adoption. The courts are not familiar with it. They've never seen a case like this.
Yeah.
It's completely new. Total white.
But I think there's a different play in the customer facing stuff to the employee facing applications. Let's stick on the customer facing application. So one of the challenges then is if there's a self-declaration of your lists of things that this bot can't be relied on, and imagine it is a bot that's providing, I've got a draining problem at the moment in my garden, right? So drainage and plumbing and flooding advice. And I'm told, well, this is a bot and don't ask it this class of questions. And even if it answers, you're to ignore it. What does it do for the consumer trust? There's a point where I'll be saying, why am I being presented with this information? What of this information can I trust anyway? And it pushes that cognitive load and that responsibility from the organization, the enterprise, back over to the customer. So this feels to me like it's a knotty problem. And if I took your proposal to the limit, it feels slightly unsatisfactory as an experience. How do we square that circle?
I don't think it's a panacea in one direction or the other. I think that, like, you as the user, us as the public, if I just think about me going online, I have some symptoms, I'm feeling sick or something, I Google my symptoms, I show up at WebMD. Symptoms map onto a wide range of different diagnoses, and I'm going to develop a certain sense of trust or distrust with different sources that try to tell me what's wrong with me or how I can treat it. That's up to me as the consumer to figure that out. And I do have a hesitancy inside. Everything that I'm reading, I'm asking myself, is this actually accurate? How much should I trust this? And so that's going to be true with chatbots as well. Like, you're going to have some sort of internal understanding of how much I can rely on this. How much can I rely on this entity? What sort of applications can I get? And as the technology changes and gets better, for instance, I don't know if I would have trusted WebMD 15 years ago, right? Like, maybe at that point on the website, it was not so good information, less trustworthy. Wikipedia went through this. Wikipedia was very volatile in terms of information trustworthiness, but now it's considered a quite robust and reliable system.
But you've made me realize something. Actually, there was something about Air Canada which was different to Chevrolet of Watsonville. So in Chevrolet of Watsonville, the end user went out to try to get the chatbot to behave stupidly, right, and get the $1 car. It was an interaction you would never have imagined a human-to-human conversation going in that direction, right? So there was a sense of maybe not bad intent, but it's a prank. Whereas in the Air Canada example, when you look at the chat logs, the user had a very decent intent. The user's grandmother had passed away. He was asking about bereavement rates, and the bot and did have a bereavement policy, but the bot gave the wrong information. And you can see that in criminal law terms, that the mens rea, the state of mind of the Air Canada user was I think, quite genuine, whereas the sort of mens rea of people who are trying to get the bots to fail is not in that sort of same level of authenticity and good intent. So it feels like there's a distinction that might be one that, particularly for larger cases of liability, would need to be adjudicated on through evidence and in a court process. But I would say that in the Air Canada case, probably Air Canada should have just paid up, right? The user came and asked an honest question, got a bad answer, acted on it, and would have done exactly the same thing if a human had given him the bad answer. And Air Canada may have fought that at that point. But I think the malintent one, the $500 billion you discussed, or the guy trying to get the car for the dollar, feels like that shouldn't be enforceable, right?
Sure. Sure.
Yeah, that feels like it's a distinction.
Using the model, using the chatbot for its intended purpose versus not, right? If you're just honestly trying to, hey, how much does this car cost? And it comes back and tells you it costs $1, that's a real issue. And so I think in the case of Air Canada, it should have been made clear that this chatbot doesn't have the authority to reduce prices, may produce erroneous information, and always you should check your sources. And I think that's why RAG is important. Something that Cohere does, which is unique to the others, is we put a huge emphasis on citation.
Right.
And so when the model responds, it's citing back to a specific document. It doesn't just respond having read a document. It responds and it has the burden of proof for why it's responding, right? It has to say, I'm saying this because I read it over here in this document, in this paragraph, in this sentence.
Right.
And so I think that's going to be crucial, not only to the examples like the Air Canada one, but also just to compliance in regulated industries. Being able to audit these models, being able to explain why they said what they said, where they found the information that they said. So citation and proving where you're getting this information from, I think that'll be important.
Is RAG the only other common thing that you add to a large language model in an implementation, or are there other common bits of scaffolding? Is there a carburetor and a handbrake and equivalents that are in all the applications?
Yeah, once they get to production, it becomes quite complicated. You have your model, which might be responding, models checking for toxicity, or if we're getting into areas that we don't want the model talking about. You, of course, have other tools. So RAG is one tool. Being able to search and retrieve information is one tool. But you can also plug it into any API. And so whether you want it to be able to update employee records via chat or this sort of thing, to do that, you need to be able to make an API call to update a database with the information you want. And so, yeah, they can become quite complex with many different sort of components watching the core behavior and giving the model the ability to reach out to APIs and databases. It
sounds like this is going to really favor companies that have already made big investments internally to have good digital systems and APIs on top of databases and processes mapped to, the right kind of workflow software. Is that reasonable? Is this a case of the well-prepared are going to have an even bigger head start in this next cycle?
I think so.
Or is there the reason I say that, sorry, and I just want to finish that thought, is that one of the strengths of LLMs compared to previous versions of AI, like these discriminative ones, was that you didn't really have to clean the data. You could literally throw the whole of the internet at it and it could make sense of it. So there is this argument that maybe you could make up for past sins if you haven't got all your data in order by just chucking it in an LLM because it's got the ability to make sense of it better than previous iterations of technology.
I think it still has that factor, which is those with the data win. If you have the data already, if you are someone who's been around for a long time, collecting a lot of rich data, in ways you're not, you're in an advantageous position compared to market. And so that's something that sort of disappoints me about AI, is that there is this facet of entrenching value. The folks who have already won the last go around, they're in the best position to win this next go around. And AI might make it easier for them to not be disrupted. That actually frustrates me. But for enterprise customers, that's great, right? That's something that you really want to adopt.
Yeah, the thing that Aidan is disappointed about with AI, I can see that's already going to go out on our social feeds when we promote this conversation. You talk about 23 was the year of the proof of concept, and I think that makes a lot of sense. I took away a couple of numbers from 2023. One was that OpenAI said that 92% of the Fortune 500 had got their developer program, which could be really straightforward. It makes me wonder, what are the other 8% doing? And then the second was that an academic from Babson College did a survey of 400 chief digital officers, and 6% of them already said they had LLM-based apps in deployment. And for me, 2024 and 2025 was about the convergence of the 6 to the 92, right? The getting all those developers who are at the grassroots and excited about using the technology, and they found the sort of lowest entry point, through to many more deployments. So 24 and 25 will be the years of deployment. What does that actually mean for the employee, right? What have you seen about employees' rhythms change when they get their tools? Do you have any way of quantifying that impact? And then we can get a sense of how that impact magnifies over the next couple of years.
Yeah, there are, with each one of our customer engagements, we try to have metrics which measure the value that our product, these models, create for the enterprise itself. And there are some pretty insane numbers that are hard to believe. For a very large, high fashion brand that we worked with, we built a system which would help them. They're retail, right? And so they're constantly onboarding new employees, and they have a huge product catalog. And it takes months, years to actually become familiar with the full catalog. And so you see seller productivity. It takes a long time to ramp. Right. When an employee is hired to when they actually start making the average amount of revenue for the company. We sped that up dramatically, like down from months into weeks, because they had a chatbot which knew the entire product catalog, which they could ask for advice. What do you think that a man in his 30s who likes such and such might want as a gift?
Aidan, I know I look young, but I'm in my 50s. When you go and get my gift, just bear that in mind, yeah.
So I think it's pretty insane, the efficiency boosts that you can get purely by.
So can you try to quantify that a bit more precisely? So it was months. Is that 3 months, 4 months, down to weeks? Is that 2 weeks, 3 weeks? Is it that sort of order?
I don't remember the actual specific number.
Fair enough.
If I'm completely honest. I think there's another example of augmenting a sales team with these bots. It boosted conversion rates by 20%. Just huge.
Yeah, it's huge.
And we always try to measure the value that we create, and some of the numbers are incredible. There's a study from MIT. I think there was another one out of Stanford or Harvard showing the productivity lift in white collar educated workers. You've probably seen this.
Yeah. There was an MIT one, and there's a Harvard one, and the Stanford one was on customer service reps. But yeah, that's right.
Yeah. So for the college educated white collar workers who tend to be like analysts, like their day to day is take in a question, do research, and return with an answer. And when you sit them down next to these models, correct me if I'm wrong, the lift is something like a 40% productivity lift, a 40% output lift. So you're doing 40% more work, and your quality goes up by 20%.
It's something like that. And actually, one of the things that's really fascinating is that you see a bigger lift on the bottom 2 quartiles of performers than you do at the top. And I actually think that is slightly unsurprising, but it also speaks to the way in which we're evaluating the very, not top quartile, but the top decile. Because I suspect that, as we saw in previous series of technology, that the top decile and the top centile do really well because they're still sort of have an edge over the technology for the time being, until you get to the point which we've got to in chess and in Go, that you're better off with the technology than you are just with the talent. But I don't think we're there yet in human work right now.
Yeah, the result that you're talking about, this idea that you can measure your employees' performance before any access to AI, and you're going to get it graded in terms of performance. And as you'd expect, the productivity of the lower performing ones is low, high performing ones is high. It is like a approximately linear relationship. Right. And then now if you give this pool of people access to AI, the line goes from this
to almost flat. Yeah.
And it's like the whole line lifts first off. So even your top performer benefits getting access to AI, but it flattens. And so the idea that AI would be this great equalizing factor for different employees of different skill levels, I think it's amazing.
I think it's really amazing. I think it raises a competitive dynamic, question of competitive dynamics. So companies that are in growing sectors of the economy will benefit quite a lot, right? Because they'll have this extra capacity, right? Suddenly everyone looks like they're top quartile. And that's amazing because you're growing really fast. In an industry which is not growing rapidly, that might be in decline, that might be about managing obsolescence, I think the challenge is that once you start to implement these LLMs, your business should win market share. And that means the other players in that business will lose market share because the overall pie is not growing. And so I think that's where you start to see wage pressure and employment pressure and firm survival pressure in stagnant sectors of the economy where maybe demand is flat, and these tools can be applied. Because what we know in those types of the economy historically is that managing obsolescence is always, to use a phrase of a British politician from the 1970s, squeezing it until the pips squeak. And that's very different to the kind of innovation economy that you and I work in, where we're just desperate for more high talent, right? Because the market is growing so quickly. So I think there is this different tail. And I imagine that companies that are owned, for example, by private equity, which has always been about kind of operating efficiencies rather than innovation, will take to these technologies with a cost reduction mindset, whereas companies that are in the growth and innovation economy, whether it's biotech or professional services or anything that's venture backed or electric vehicles, renewables, will take these technologies as a productivity maximizing growth strategy tool that you can use. And that's what we would expect. In a sense, that one of the things that you and I have discussed over the last hour or so is the continuity of this technology against previous technologies that we've seen. I don't think either of us have said this is so radical that it really changes everything. Is that reasonable?
I think so. I would say it does change everything. It touches every part of our day-to-day, our economy. But I think you're right in that it's an augmenting force. It doesn't, I don't think that it's going to completely disrupt our way of life. I think that companies go into obsolescence, talent flows towards the higher growth areas. This is natural. And I don't think AI changes that pattern. Maybe it can be used to help that talent flow from the low growth, declining sectors into high growth opportunity sectors. But I don't think it displaces people in a way that's catastrophic or harmful. I think humanity is profoundly supply constrained. The folks who we're talking about helping here, white collar, college educated workers, the world doesn't have enough of them. And so if this helps them do more, it's not people losing their jobs. It's us actually satisfying the demand that exists out. We'll increase our supply. And so that's my perspective. This isn't going to be a disrupting technology in the sense of displacing people, pushing people out of where they're comfortable. I think it'll be hugely positive and augment to humanity as opposed to displace.
Cohere is working with very well-known big brands, but what if you're a 1,000, 1,500 person company where the total IT budget is $35 to $50 million a year? That includes all of your operations, your cybersecurity, your license upgrades to Microsoft Office, and for you a $250,000 investment in a year will be the big single new project that you do as an organization. And so you really need to get that investment right. For an organization that's at that scale, are LLMs not for them for another few years, or can they actually do something today?
I think they really should do something today. I think the way you do it is going to be different than someone who has infinite budget and can do whatever they want. You need to be very picky about what project you pursue, and you need to be picky about who you choose to do it with. I don't think that all model providers are created equal. And you need to pick someone who's going to be your partner. You need to pick someone who deeply needs you to succeed. I think that is how we've thought about structuring ourselves at Cohere. We want to be that partner. We want to be building alongside our customers and ensuring that they succeed. They might not have the technical sophistication of research labs or the trillion-dollar market cap companies. And so we want to help them compete, and we want to bring that expertise in AI to make sure that they succeed.
But could I do something of any value with $250,000 or even as much as $500,000?
100%. This technology is insanely cheap. If you just look at the price per token and how quickly it's falling, like, cost is not the barrier to adoption. It's product vision or vision for a project that you want to pursue, as well as the ability to execute. And so that's why you need the partner who knows the technology, can push you through those sticky, difficult bits. But cost is really not the barrier. I think I should be clear, cost can be the barrier. Like, if you look at GPT-4, a massive model, that is prohibitive.
That's expensive. It is prohibitive. Yeah.
And so, again, that's why I say pick your partner. Pick someone who's going to help you build technology that actually scales. Last year was the year of the POC. Everyone was building with GPT-4, the largest models possible, because it's 5 people using the POC. It doesn't matter. Like, scalability doesn't matter. Cost doesn't matter. Okay, now you're going to push that to 10 million users. You care a lot. The whole equation. So you care a lot about efficiency. So for Cohere, like, my focus has been on building a technology stack that can scale. That can scale, is cost effective, that after doing a POC, we can just press go and push the product. We don't need to refactor everything. And so that's been a very big priority. And I've seen it a lot in industry of folks getting burned by using massive, hyper expensive models during the POC and then having to redo all the work in the POC because they couldn't economically make that work.
Yeah, in a lot of the companies that I've spoken to, many of them are startups who are quite far down the track of building products built around LLMs. They're using many different LLMs. They're using LLMs via using hosted APIs. They're using their own open source, sometimes on their own cloud, and they're making many product decisions. And it just reminds me of the way we used to have to build apps when Amazon first came out with AWS, and you had S3 storage, which was cheaper but slower than the storage that you could have attached directly to the machines. And then you had the long duration storage, and you had hosted databases, and they all had different costs, latencies, other types of attributes. And as a product designer, you had to say, what are the ones that we're going to put together for different parts of the application, given what we can afford? Ideally, you want all of your customer data in the on-chip RAM, right? But that's the most expensive memory anywhere in the world. So we have to make compromises, and we do that at the cost of latency. And it feels like when we're building these apps in LLMs, we're going to face a similar set of decisions, right? There'll be points where we'll be saying, actually, we have to hit this so often and it has to come back so quickly, but we don't need it at the quality. So where's the cheapest way of doing that? And other places where, we need a really precise, methodical construction with a bunch of RAG, and we're going to use a different component there, right? It's similar. Is it similar types of architecture decisions that we're talking about then?
Yeah. They do balancing cost with performance, whether that's money or efficiency. I think that's what you're balancing. And it's going to be a heterogeneous set of different models. The efficient one can serve 80% of use cases. The inefficient, expensive one has to be the one deployed to serve those harder 20% of use cases. That might be the system stack that we evolve towards. But right now, I just see everyone getting caught in this trap of not thinking about scalability from the outset and then getting flat-fooled at the end.
Because ultimately, you have to effectively rebuild your system as you go into production. Aidan, you had said you had a lot of optimism about the ability for employees to continue to grow in the space of these large language models augmenting their work. And I'm curious, what are the effective methods you've seen organizations use to bring employees alongside the development of AI-based tools?
I think media is definitely pushing a narrative of fear because fear sells. And so displacement, you should be scared, loss are coming for your job. I, I think that's a very effective way to sell clicks, get views, but I don't think it reflects the reality of how people who are actually using this technology feel, the employees who are using this technology feel. A great example of this is the fact that there were a lot of concerns around data privacy with chatbots. And rightfully, because these employees were adopting this technology, making it part of their day-to-day work, and putting a lot of extremely confidential information into public chatbots where the data can be trained on. And so it was a huge liability. And so a bunch of the general counsel, the legal departments of these companies, they shut it off. They said they made a policy, you cannot use chatbot A, B, or C at work as part of your job. And employees didn't care. They still did it. They needed this technology. It became like a key piece of their workflow. Yeah. And so I think what that tells you is that it's a necessary piece of getting your job done for so many people. And the way that they've gotten to that position, the way that this technology has become so useful and adored by them is by needing it and being part of the adoption story. And so when you're thinking through, if you're looking for internal productivity enhancements and you're thinking through how to do that, you better involve the stakeholders, the people who are actually going to be using the tool, and have them tell you, this is what would make my life easier. And giving them a platform to experiment with the technology, not just banning it outright, but standing up a private instance of Cohere that you can chat to so that people can get firsthand experience. In the same way that I was talking about in 2023, it was like the firsthand experience with the technology that let people see the product opportunity, that let people develop their own vision. The same is true for your employees. You need to give them a safe space, like a sandbox to explore and experiment.
It does seem you've got this super general technology. As a result, you need the front line to be able to identify where it could actually be used in real problems. And in order to do that, you have to expose your users to the technology in the first place. I also think culturally, that's the way companies have moved anyway. After years of top-down restructurings, we do these sort of syncretic, group-wide transformations now, right? And people are involved in them. So I think culturally, there's also a sense that this is how those decisions should get made. So it all seems to fit together. But the idea of the sandbox, I think, is quite an interesting one. It's almost the sense of we need to get this to work. We should just get something that looks at some of our proprietary data. So we're not just playing with internet data, but it's in a safe space. And out of that can come the discovery of the applications that we then start to build.
Yeah, that's absolutely correct.
And you're going to continue to grow, as are many of your peers and competitors and complements. But is it all going to be on LLMs? LLMs and the transformer architecture, they're 7 years old. They have got room to run, develop, and mature. But how do we measure their progress? And how much longer do we have on this particular architecture?
I do not think the transformer was the last word. So I would be, as an academic, I would be extremely disappointed if this was the best we can do. And like I said, it was hacked together in 3 or 4 months. There has to be something better.
So what are they not doing? So for you, what are the things that the transformer is not doing that would make these systems better?
I think first off, the transformers that we train today do have a lot of improvements over the transformer we built 7 years ago. So we've made progress. I'm a firm believer that we've made some progress. We still call them transformers, and there's a question of like whether SSMs or these new state-space models, these new versions of model that are coming out, will we assign a new term to them, or will it just be a transformer that has a state, a recurrent element incorporated into it or backported into it? I don't know, but I definitely do see something coming. There are components of the transformer that are inefficient, quadratic cost of attention, which is very expensive if you have very long documents, very long words, very long instructions. And then hampers scalability, which is the core bottleneck to us improving the technology. So SSMs and borrowing these ideas from recurrent networks, keeping a state, I think they're very exciting. I hope they replace transformers. I hope that we get the tech stack, the software stack in a place where it's efficient enough and it's sufficiently optimized that we can swap them in for a transformer and then
but that addresses the question of scale, right? And the kind of computational cost and complexity. But if you hear other people with differing opinions, like Gary Marcus and say Jan LeCun, they also resolve around a couple of issues, right? The ability of the transformer to reason, the ability of these architectures to do planning, a reason for them to be able to give explanations about their world model rather than generate things that look like the world. Do you think those are salient directions of travel, and those are problems that get solved in this general space, or are they not relevant to the business of enterprises and AI?
they should go very well.
Right.
If they have compliance, they should go relevant. Could be the work. I think a lot of the criticisms are vapid. They point to like short-term localized issues with architecture technology, which can be patched and that we are working on improving via either changing the architecture, changing how we train them, the signal that we give the models to learn. It's just really vapid critiques, which have tended to come from folks who have been repeatedly wrong. And so I guess my response would be, go build it there well.
Yeah, I think one of the points that you've made in our discussion is that a lot of these things are the early moments of friction, right? That you face when you build a new product. When we first had trains, passengers were being inundated with smoke, right? And then we figured out how to reduce the amount of smoke that comes into the carriages. And you see a whole set of innovations in cars like pneumatic tires that evolved to make the journey smoother. And I think one of the games here is arts is to recognize that there are steps of improvement, one of which I think we discussed quite a lot of was a retrieval augmented generation as a way of anchoring models into reality. And the other thing that we've seen on the question of reality has been the hallucination rate of models has really declined over the last 5 or 6 years. But I was curious about whether there are specific types of tasks, like reasoning being one or long range planning being another, where a new architecture might be required, or whether actually you could do that through productization of the existing architectures, right? So you could actually get to a world where you could get a model to come up with a complex, multi-part, multi-step plan, but you just need to chunk it in particular ways to get it to work, or whether you actually just need a fundamentally new architecture in order to do something like that.
The architecture is just like a way to store knowledge. It's basically just a way to store information. And I think one of the observations over the past decade of AI has been that the architecture actually matters very little. Like the way that you structure that knowledge, the way that you structure that capacity, it doesn't really matter. What matters is the raw capacity, how much knowledge it can convey. Okay. And so if you're going to come up with something that does better timing, that does better reasoning, it's probably going to come from the way that you inject knowledge into that architecture, as opposed to changing the architecture itself. Lots of people love to point to the architecture and say that this is what's inhibiting us. If you only improve X, Y, and Z, everything would change. Go build that architecture, run it. You just do it. It's right there. Right. I think the difficult part is actually getting the behavior to be what you want by changing the like whether you're using RL or self-play or these sorts of ideas. I think pointing to the architecture and assigning blame to it is the cop-out. And it's a bad one because it's so easily intervened on. You just imbue the structure into the model that you want to do it, run it, see if it's better. You can prove immediately right there
Yeah. And I think you've been pretty consistent in our conversation about the importance of scale, right from the original discussion about the transformer paper back in 2017, the importance of understanding that what scaling delivers and why, therefore, you have to think about scale right from the beginning. So by hearing correctly that it comes back to a question of achieving that scale efficiently gives us lots of room to run. And the idea that we might be hitting scaling limits may be connected to the sort of the inefficient scaling of certain ways of building these models.
Yeah, like the most salient argument for what is the future of architectures in neural networks is what efficiency gains remain to be had. That's what will steer the next architecture. It's quite low level, right? It's literally just benchmark as opposed to what gives you better reasoning and planning. And then I think it's been a huge shock to me, and I think a lot of others, how far scaling can take you. Like how much better the models become as you grow them by 10x, 100x, 1000x, 10,000x. And there is that open question of how long can we keep this up? How long can we just keep pushing on scale and it delivers returns? I don't have an answer to that. I think we probably have total order of magnitudes to go.
Like 100x.
Yeah.
And how would you address the data question, right? So we've done the whole of the internet. So is it now a case of getting inside corporate stacks and then getting transcripts from TV shows and documentaries and just trying to find more data where we can? Or is there some other strategy we need?
No, that's exactly right. I was going to say, as you're scaling up the model, while you're doing that, while you're the place where you have to intervene is on the data. You can make the data cleaner, more complex, more robust. You can get access to proprietary sources of data that make it perform better in a domain that you care about. And so data is the other. Scaling, we're going to keep pressing on. We're going to keep scaling up. I will keep driving. But on the data side, there's so much work to be done. What we do right now is still very naive.
Yeah.
And so I think data, scale, and then learning algorithms. How you actually take the data and extract value from it, learn from it. Another area where I'd say that we have a lot of work to do.
But one of the things I saw Microsoft do at the end of 2023 was they took a consumer chatbot and they fine-tuned it with curated medical data, a small amount of really high-quality data, like relative to the billions or trillions of documents that have tokens that have gone in to the consumer chatbot, and it outperformed a perfectly curated medical bot, I think the MedPalm model, on a whole bunch of medical data sets. So that says that alongside scale, there's also the power in the kind of cleaning and curating, and the power that comes from the weight that is given to the highest quality data within the system. So that's not purely a scale game, right? That is another lever that we can pull on to get performance out of the models.
Yeah, that's what I was saying with scale and data being separate. There's on scaling up the models, and that will try to benefit them.
Right.
But on data, you actually might want to go down, and you want to reduce the amount of data and just focus on the highest quality sources.
It is what is fascinating in this conversation, and we're coming to the end of it, is that even where we are today, there's quite a lot of room to run, right? There's the enterprises moving from POCs through to production. There's the questions about how do you scale models? How do you get the right data into models? It feels very foothills. And yet there is undeniably a torrent of stuff that is going on, right? My inbox is full. Archive, which has these preprints of papers, has so many new results every year. There's commercial competition between you and some of your peers that are pushing certainly kind of technical performance specifications up, not by 10% each time, but by an order of magnitude each time. I'm curious about how you personally hold those two things in your head at the same time. I found this is our third or fourth conversation. You're always very level-headed about the way you look at the world and how you talk about things. But at the same time, there is also this 10xing that appears to be going on amongst you and your peers. Like how is that resolved inside the sort of black box in your head?
Yeah, it's a big field that's gotten a lot of attention, a lot of resources, and so it can be overwhelming. And there is definitely tons of stuff that's happening. My honest opinion is that it's not happening fast enough. Like, we should have much more progress. Right now, the release cycle for models is basically one a year, which for any product team is insanely slow. And it's unfortunate because there are really impactful, good applications of this technology that we can't deploy it against because it's not good. So even if we are 10xing, seems like fast from the outside. I think the feeling from the inside is that it's too slow and that we should be doing more, we should be getting more done. That's at least how I felt for the past 5 years, is everything's happening too slowly.
And on that cliffhanger, because I want to ask you, how do we go faster? What happens if we do go faster? What are the levers you would pull? We're going to have to stop here, but maybe we'll get a chance to continue that conversation at some point in the future. Aidan Gomez, thanks so much for your time.
Thank you for having me.